Hello. So we were discussing trigonometric identities, and we were doing exercise 8.4, and we had already done 4 problems of question 5, exercise 8.4. So let us continue from problem 5. So problem 5 was cosine of A minus sine of A plus 1 divided by cosine of A plus sine of A minus 1 is equal to cosecant A plus cot A. So we have to prove this LHS is equal to RHS. So we had decided that we will follow a simple procedure for now, that is convert everything to sine and cosine. But when you look at the left hand side, there is nothing like tangent, cotangent, cosecant, secant. There is nothing like that in the left hand side. It's already in cos and sine. So there is nothing like we can further simplify at this time. But when you look at the numerator and the denominator, you will find the similarity that over here we have cos here. There's minus sine A plus 1. And over here is sine A minus 1. So if I do this, if I write it like this, 1 minus sine A. And if I write it like this, then you can see, yeah, this is a bit similar. I have just taken the negative sign outside in the denominator. Why have I done that? Because I already told you a square minus b square is a minus b into a plus b. We have seen this before, and I have told you already we will be using this identity a lot in this chapter. So let us try use it again. How will I use it? I want to change this to a square minus b square. This will be my a and this will be my b. 1 minus sine a. So I already have a minus b. I need a plus b. So let us multiply a plus b on both the numerator and the denominator. When I multiply this with 1 minus sine a, what will I get? We will see in the next step. So this whole is my numerator. And what will be my denominator? Denominator will be cosine of A minus 1 minus sine A. This will be multiplied with cosine of A plus 1 minus sine A. Okay, so now this is cosine of A plus 1 minus sine A. This is also cosine of A plus 1 minus sine A. So this A plus B into A plus B is A plus B whole square. Now we know what is A plus B whole square. A plus B whole square is A square plus B square plus 2AB. So what will be my left hand side? Left hand side will be cosine of A squared plus 1 minus sine A squared plus 2AB. So 2A is what? Cosine of A, and what is B? 1 minus sine A. So this is looking a bit challenging or a bit tough, but you shouldn't worry. It will work out in the end. And this is a minus b into a plus b, so it will become a square minus b square. And what will be a? A is cos a, so this will become cos square a. And what is b? 1 minus sine a. Okay, so a square minus b square. Now this is again 1 minus sine a whole square, so we will have to expand it. We know that a plus b whole square is this, but do we know a minus b whole square? Yes. only this sign changes to minus. So we will have cos square A plus 1 plus sine square A minus 2AB. So minus 2 sine A plus 2 cos A into 1 minus sine A. So I don't want to open this bracket as of now because I want to see what will happen to my squared terms first. Okay, so this is the numerator. And let us have a look at the denominator. Again, this is a minus b whole square. I will have to operate on this. So I'll get 1 square plus sine square A minus 2ab, so minus 2 sine A. Okay, don't mind the whistles, my wife is cooking food. She's making dinner early. Okay, so cosine square A plus 1 plus sine square A. Cos square A plus sine square A we know is 1. So we get 1 plus 1 minus 2 sine A plus 2 cos A into 1 minus sine A. Actually, this problem is quite tough. It is one of the tougher problems in this chapter as I have seen. So don't be disheartened if it's looking a bit too tough for you right now. Just deal with it. Okay, what is 1? 1 I can always put in as cos square A plus sine square A, yeah? But because there is a negative sign outside of it, we will get minus cos square A minus sine square A. Okay, and so this is plus sine square A and there is minus sign outside, so this will become minus sine square A as I open the bracket. And this is minus 2 sine A and there is another minus sign over here, so this will become plus 2 sine A as I open the brackets. So this will get cancelled. Now what will be my left hand side? 1 plus 1 is 2. So 2 minus 2 sine A plus 2 cos A into 1 minus sine A divided by minus sine square A minus sine square A, so 2 times, so minus 2 sine square A plus 2 sine A. Now the magic will happen because in the top you can take 2 common from here. What will you get? 2 into 1 minus sine A. You also had 2 cos A into 1 minus sine A. In the denominator I want to write it like this: 2 sine A minus 2 sine square A. I will take 2 into 1 minus sine A common. What will I be left with? I have taken all of this common, so only 1 will be left. And from here I have taken 2 into 1 minus sine A as common. What will be left? Only this, 1 plus cos A. And over here I can take 2 sine A common. What will I be left with? 1 here. 2 sine A is taken common, but I have 2 sine square A, so I will be left with sine A over here. Oh, look at this. I can cancel this out. I can also cancel this out. So what will be my LHS? 1 plus cos A by sine A. And what is my right hand side? Cosecant A plus cot A. Convert everything to sine and cos. Cosecant is 1 upon sine. Cot is cos upon sine. Take the LCM. LCM is sine. So sine A. What will I be left with? 1 and cos A. So my left hand side and my right hand side are looking exactly same. They're equal. So left hand side is equal to right hand side. Done. We have proved the identity. So this was a tough question. So if it's taking a little bit of time for you to understand it or let it sink in, so don't be too worried because it was a tough question. Now let us look at question 6. We have to prove 1 plus sine A over 1 minus sine A is equal to secant A plus tan A. Now have a look at this left hand side again. It is a square root of 1 plus sine A by 1 minus sine A. As I said, A square minus B square will be used again and again in this chapter, and I'm going to use it again. How will I use it? I have A and I have B. I have A minus B here, so I need A square minus B square, so I'll multiply it with A plus B. Since I'm going to be multiplying this with A plus B in the denominator, I have to do the same in the numerator. 1 minus sine A into 1 plus sine A. 1 plus sine A into 1 plus sine A. So now in the numerator you have A plus B and A plus B multiplied again. So A plus B whole square. Yeah. 1 plus sine A whole square. And in the denominator I have A minus B into A plus B. So that is A square minus B square. So this is square root of 1 plus sine A whole square divided by 1. 1 square is 1. Sine square is sine square. No changes here. So, but we know that sine square A plus cos square A is 1. So 1 minus sine square A will be what? It will be cos square A. So I have 1 plus sine A whole square by cos A. So this is the square root and this is a square, so these two will get cancelled. So I will get 1 plus sine A in the numerator. In the denominator as well I have square root and cos square, so it will get cancelled and I will get this. So this is my LHS. Now look at my RHS. Right hand side. It is secant A plus tan A, tangent A. So what can I do? Convert it to sine and cos. So 1 by cos A, tan is sine by cos, sine A by cos A. LCM is cos A. I will get 1 here and sine A here. My LHS and my RHS are exactly the same, hence proved. 1 plus sine A by cos A and 1 plus sine A by cos A. So I have proved that LHS equals RHS. Sixth one is done. Now seventh one. Okay, this is looking a bit tough. Sine theta minus 2 sine cube theta by cos 2 cos cube theta minus cos theta is equal to tan theta. Now we know that tan theta is sine theta upon cos theta. So in the LHS, I will necessarily have sine in the top and cos in the bottom. Let us see how we will achieve that. Sine theta minus 2 sine cube theta by 2 cos cube theta minus cos theta. So I need tan theta in the right hand side. Tan theta is sine upon cos. So I need sine here in the top and cos in the bottom. How do I get that? Easy. I will just take sine theta common. When I take sine theta common, what will I be left with? 1 here. And this is degree 3. So I have taken 1 sine outside. So I will be left with degree 2. Okay. And when I take cos theta common from here, what will I get? 2 cos square theta minus 1. So I will have sine theta by cos theta here. Now sine by cos is tan, so I need tan theta. That's it. I got my tan theta. But I don't need this. So all of this will be equal to what? 1. I just need to prove that this is equal to 1 and I'm gold. I am gold. How do I get that? It's easy. Either I convert sine square to cos square or I convert cos square to sine square. Let us say I convert sine square to cos square. How do I convert sine square to cos square? I'll just put 1 minus cos square theta. I just need to open the brackets and I can promise you this problem is done. So tan theta into, when I open the bracket, what will I get? 2 into 1 is 2. 2 cos square theta minus and minus plus, so plus 2 cos square theta. And here 2 cos square theta minus 1. Okay, so I will write it like this. Tan theta into 2 cos square theta. Now over here I have plus 1 minus 2. 1 minus 2 is minus 1. So 2 cos square theta minus 1. This will get cancelled. I got tan theta, which is equal to RHS. So LHS equal RHS, hence proved. We are done. Now let us look at problem 7. Problem 7 says, this is an easy problem. Sine A plus secant A whole squared. This is very easy. I don't even want to do it, but let us do it anyway. This is like the easiest problem in this question set. I have LHS, which is equal to sine A plus cosecant A whole square I also have cos A plus secant A whole square. Now we don't want to do much of work here. Just change everything to sine and cos. So sine A plus cosecant A is what? 1 by sine A. Okay. Plus cosine of A. What is secant A? Secant A is 1 by cos A whole square. So A plus B whole square, we know A plus B whole square, right? Sine square A plus 1 by sine square A plus 2AB. A is what? Sine A. B is what? 1 upon sine A. Okay, so this will get cancelled. I will be left with only 2. And over here, a square plus b square plus 2ab, 2 cos a into 1 by cos a. This will also be cancelled. Now I have sine square a plus cos square a, which is what? 1. I just want to write it as cosecant square a. I will tell you the reason why in a second. Cosecant square a plus, this was 2, plus 1 by cos square a. I want to write it as secant square a. This is 2. So 1 plus 2 plus 1 is what? 1 plus 2 plus 2 is 5, plus cosecant square a plus secant square a. Now in the RHS, what are we given? We are given 7 plus tan square a plus cot square a. We have already reached 5. How can we go to 7? We just write this as 1 plus cot square a, and I will write this as 1 plus tan square a. Right, these two are the identities that we have already proven before. So 5 plus 1 plus 1 is 7. 7 plus tan square a plus cot square a, which is my RHS, hence proved. So this is done. So this was a really easy question, very easy question. Now look at 9th. Cosecant a minus sine a into secant a minus cos a is equal to 1 by tan a plus cot a. So this is looking like really tough problem, but believe me, it only looks tough, it isn't tough. If we follow what we have been doing till now, just convert everything to sine and cos. Convert everything to sine and cos, and life will be easy and chill. Multiplied with secant a minus cos a. Okay, so how do I change cosecant to sine? I just do this 1 by sine a minus sine a. Yeah. What is secant in terms of sine and cos? This secant a is just 1 by cos a minus cos a. Take the reciprocal. 1 by sine a minus sine a will be sine a. I will be left with 1 here, and sine will be multiplied with sine. I will get sine squared. Similarly, over here I will be left with 1 minus cos square a by cos a. We know that 1 minus sine square a is cos square a. 1 minus cos square a is sine square a. But look at my denominator. I have a sine a here, and a cos a here. So this cos will get cancelled with this, sine will get cancelled with this. I will be left with cos a sine a. But this is not what my right hand side looks like. Right hand side is 1 by tan a plus cot a. I will have to simplify this one as well. Right hand side is 1 by tan a plus cot a. Tan a plus cot a. How do we simplify this? We will do what we have been doing all throughout the chapter. Convert everything to sine and cos. So tan is sine by cos. Cot is cos by sine. Now we take our LCM. Cos a sine a. Sine will be multiplied with sine, so get sine square A. Cos will be multiplied with cos, so we will get cos square A. Sine square A plus cos square A is 1. This will go here, so I will get cos A sine A divided by cos square A, sine square A plus cos square A, which is 1, and we had 1 here, so 1 multiplied with this will just stay the same. 1 divided by 1 will stay the same, so cos A sine A. So my RHS is cos A sine A. My LHS is also cos A sine A. So LHS equals RHS, hence proved. Now we are left with the last problem. This is 1 plus tan square A divided by 1 plus cot square A. This is equal to 1 minus tan A by 1 minus cot A whole square, and this is equal to tan square A. So this is no LHS equals RHS. There are 3 terms, 3 expressions, and we have to prove all of them are equal. So let us first look at this one. 1 plus tan square A by 1 plus cot square A. So this is a simple identity, right? 1 plus tan square A is what? Secant square A. And 1 plus cot square A is what? Cosecant square A. So convert this to sine and cos. Secant square A is 1 by cos square A. Cosecant square A is 1 by sine, right? 1 by sine square A. So this is in the denominator of the denominator, so sine square A will go up. So I will be left with sine square A by cos square A, and sine by cos is tan, and both of them are squared, so I will be left with tan square A. So I have proved that this is equal to tan square A. Now I have to prove this is also equal to tan square A. So let us have a look at this. 1 minus tan A by 1 minus cot A whole squared. Again, what we have been doing, convert everything to sine and cos. Whole squared. So what will I get? In the top I will get cos A minus sine A by cos A. In the denominator I will get sine A minus cos A by sine A. This is whole square. This is the big divisor. So what will I do is I will take this up. Cos A minus sine A by cos A into sine A by sine A minus cos A. Yeah? And this is whole squared. Now if you look at this, this is cos A minus sine A, and this is sine A minus cos A. So what will I do is I will just take the negative sign outside. I will be left with this sine A minus cos A into sine A by cos A into sine A minus cos A whole squared, square on the top of the whole expression. So this is equal to this now. because I wanted to do that. That is why I have taken negative sign outside. So I got negative, and I got sine by cos. Sine by cos is what? Tangent of a whole square. So tan square a is tan square a, tan a whole square. Minus and minus is plus, so I will get plus tan square. Hence, I have also proved that this is also equal to tan square a. Hence, proved. So we are done with this trigonometric identities problem.